Welcome everyone to this explainer. I am so thrilled you're here today because we are about to completely dismantle a major cornerstone of classical economics. For decades, the standard economic model just assumed that you and I are perfectly rational actors, that we're basically calculating machines who flawlessly weigh probabilities and maximize our expected utility at all times. But let's be real. If you've ever held onto a losing stock just hoping and praying it bounces back, or if you've ever bought a lottery ticket, you know human behavior is way more complicated than that. So today we're taking a really rigorous master-level journey into Chapter 3 of Dr. Erlander Johnson's work on ethics and behavioral economics. We're going to deconstruct human choice by diving deep into prospect theory and loss aversion.
Okay, let's just quickly look at our roadmap for today. We're going to cover the failures of expected utility, then the value function, probability weighting, the fourfold pattern, loss aversion in action, and finally, mental accounting.
All right, diving right in. Section 1, failures of expected utility.
I want to challenge you right off the bat to see if your own mind actually obeys the supposedly perfect rules of classical economics. Let's put you in the hot seat with the classic gamble. Here's a scenario. Would you prefer a guaranteed £3,000 or an 80% chance of getting £4,000? Take a second to think about it. Now, from a strictly mathematical standpoint, the gamble actually has a higher expected value. It's £3,200 to be exact. And yet, when presented with this exact choice, the vast majority of people will take the guaranteed $3,000. We will literally leave mathematical value on the table just to get the peace of mind of a sure thing.
So, what you likely just experienced is what we call the certainty effect. Essentially, certainty carries a massive psychological premium when we're dealing with gains. But here is where it gets absolutely fascinating. What happens if we flip the whole scenario to losses? If you had to choose between a guaranteed loss of £3,000 or an 80% chance of losing $4,000, suddenly you become a risk taker. You'll take the gamble just to avoid that sure loss. And this is called the reflection effect. Finally, we also have the isolation effect, which is where people completely disregard the components that options share and focus only on what distinguishes them. This leads to wildly inconsistent choices depending purely on how a problem is framed. These three effects, certainty, reflection, and isolation, they completely violate classical utility functions because they prove definitively that our risk preferences systematically shift.
Which brings us to Section 2, the value function.
Now, I know equations can look a bit dry, but these formulas are absolutely brilliant because they literally translate human psychology into hard math. The top formula represents how we value gains, and the bottom shows how we value losses. Notice that little lambda symbol in the loss formula? That represents our loss aversion factor, and empirical data shows that lambda is roughly 2 to 2.5. Think about what that means. It mathematically proves that a loss feels more than twice as painful as an equivalent gain feels good.
Now, what's really interesting is seeing how those formulas actually look when graphed out. Notice that distinct S shape. The axes cross right there in the center, and that is our reference point. You see, we don't actually care about our absolute wealth. What we care about are the changes from where we currently stand. And if you look closely at the arrows on the curve, the teal ones show the subjective value of a gain, but the rust-colored arrows show the impact of an equivalent loss. Those rust arrows are visibly steeper. That visual asymmetry, that is loss aversion made geometric. It perfectly captures why the pain of losing 100 pounds stings far, far more than the joy of finding 100 pounds on the street.
Moving on to Section 3, probability weighting.
Okay, imagine a perfectly rational robot. For that robot, probability is a straight 1-to-1 diagonal line. A 10% chance is just a 10% chance. But the solid curved line here is how we process probability. Notice how it forms this inverse S shape? It rises super steeply right at the beginning, which means we dramatically overweight extremely small probabilities. Then it kind of flattens out, crossing that rational baseline around 0.35, meaning we actually underweight moderate to large probabilities. And finally, it spikes up again right at the very end because, as we discussed, absolute certainty carries that massive psychological premium.
To really put a number on this cognitive distortion, consider how we react to a tiny 1% chance of an event occurring. To our boundedly rational brains, a 1% objective chance actually feels like a 5.5% probability. Just think about that. This single numeric distortion brilliantly explains so much weird human behavior. It explains our seemingly irrational demand for lottery tickets, right? We completely overweight that minuscule chance of winning the jackpot. And conversely, it explains why we buy expensive catastrophe insurance. We vastly overweight the tiny, tiny chance of absolute disaster.
All right, let's step into Section 4, the fourfold pattern.
This framework is like a giant puzzle coming together, brilliantly illustrating exactly how complex our decision-making is. It's a 2x2 matrix crossing gains and losses against high and low probabilities. If you have a high probability of a gain, you're risk-averse. You just lock in the sure thing. But if you have a high probability of a loss, you become risk-seeking. You'll gamble desperately just to break even. Conversely, with low probabilities, that overweighting effect takes over. A low probability of a gain makes you risk-seeking, hence buying the lottery ticket. A low probability of a loss makes you risk-averse, so you buy the insurance. This perfectly explains why the exact same person can be a super cautious insurance buyer in the morning and a highly speculative lottery player in the afternoon.
Section 5. Loss aversion in action.
So the really crucial point here is how loss aversion actually manifests in our everyday lives and transactions, and that brings us to the endowment effect. Just look at the equation. Your willingness to accept compensation to give something up is equal to lambda times your willingness to pay to acquire it in the first place. Because lambda is roughly 2, the second you take ownership of an item, you instantly demand twice as much money to give it up than you would have ever paid to buy it. Giving up something you own feels like a loss, and, as we know, losses loom twice as large as gains.
And this isn't just about trying to sell a used car or a coffee mug. This fundamentally shapes life and death societal policy. Consider organ donation. In countries where the system is opt-in, meaning the default is that you are not a donor, consent rates usually hover under 30%. But in nations with an opt-out system, where the default is that you are a donor, those consent rates absolutely skyrocket to over 90%. A staggering 90+% rate proves the massive, undeniable societal power of status quo bias. We basically treat the default option as our reference point, and moving away from that default, well, our brains process that as a loss.
Finally, Section 6. Mental accounting.
The crazy thing is, we irrationally categorize our money into entirely different mental accounts based purely on where it came from or what we intend to use it for. Money is supposedly fungible, but not to us. Think of the house money effect. If you win cash at a casino, you gamble way more recklessly with it simply because it doesn't quite feel like your money yet. Or take the sunk cost fallacy. We see this all the time in high-stakes environments, like the NBA draft. Teams will irrationally keep playing a terribly performing player just because they spent a high draft pick to get them. They're just trying to avoid realizing a loss in that one specific mental account, even though the cost is completely sunk and unrecoverable.
All of this brings us to a really profound question that we absolutely have to ask ourselves as we wrap up this explainer. When you hold on to a losing stock, or demand twice what your car is actually worth, or stubbornly stick to a default choice, are you acting irrationally? Or are you simply responding rationally to your own cognitive architecture, to deeply ingrained mental software that you literally cannot fully override? The very next time you make a financial choice, I want you to ask yourself, who exactly designed the choice architecture you are stepping into, and are they actively using your predictable human nature to their advantage? It's a fascinating and, honestly, slightly terrifying thought to leave you with. Thank you so much for joining me on this deep dive into prospect theory. Keep questioning your choices.